Right, so in the previous class, we looked at part creation, and under that we had the 2D sketch with the depth, also called extruded boss or base. We had the revolved boss or base, 2D sketch and an axis of revolution. We had the swept boss or base, which was a 2D sketch and a path to follow. And loft is just filling up the volume between 2D sketches. Just one note with loft, the 2D sketches have to be in different planes. Obviously, you can't fill up the volume with between two things that are in the same plane. It will be a zero volume because the thickness is zero. Okay, then in the last class, we looked at how to make assemblies. And in today's class, we're going to look at how to make drawings. So click on New, Drawing, and then OK. Now when you do that, you get this sheet format or size block that pops up on the screen. So generally what you want to do is you want to look for the paper that you want to draw on. And to do that, you can click on Browse. And then I saved the UP drawing template that you can download from ClickUp. On ClickUp, if you log in and click on the SolidWorks content area, then at the bottom, or second from the bottom, there's a file called UP drawing template. So if you save that one to your computer, that's basically the SolidWorks' paper predefined with our drawing template from UP on it. So what I do is I would go to the top of this little menu here and then Control C to copy it. Then I paste it in Explorer and press Enter. And there you will see all of the different drawing templates that SolidWorks has. And the one here at the bottom is the one that I downloaded from ClickUp, and then I just saved it in this folder over here. Saving it in this folder means in future when you open SolidWorks and want to make a drawing, you don't have to remember where you saved it. It's automatically there where all SolidWorks' drawing templates are saved. So that's very handy to just go and copy and paste it into this file. And then close. Right, so with SolidWorks, when it says select the drawing, I clicked on Browse, and now I'm clicking on my one that I saved there, and then click on Open. And then click on OK. So now my paper is the UP drawing template. Next, it wants you to add a model, like an assembly or a part file, so that you can make your 2D drawing. For now, I'm just going to skip this and just talk about the title block and other settings for a moment. If you by accident chose the wrong paper and then made your whole drawing and afterwards realized that you didn't use the correct paper, you can change it afterwards by going to an open area in the page and then right-clicking, then expand the menu and click on Properties. And there we can set the sheet name, the scale, choose whether it should be third angle or first angle, and there you can go and browse for your drawing template that you want to use. Click on Apply Changes and then you have your paper. Right, next thing that is quite important is the plagiarism statement. So the only thing different from this paper to your practicals papers is that this one has a plagiarism statement on it. In your practical, you're drawing it while you're sitting there, so you can't really copy it from someone else or have someone else do it for you. With the CAD assignment, it's a bit different, so we added this plagiarism statement. Just says I understand what plagiarism is and I'm aware of the university's policy in this regard. You can go read through the others. And there we have a line, and on top of that line you make your signature in pen. It's going to be difficult to make it on the computer. So you print it out and then you sign it. Alright. So that's our drawing sheet. Next what we can do is we want to start to make a drawing of components. So to do that, we go to View Layout, and then the second option is called Model View. If you click on that, you get the Model View tool that says select a part or assembly from which to create the new, the view, not the new, then click Next. Now we can browse and then go search for the part of which we want to make a drawing. This is just a random part that I'm selecting. And then here on the left hand side of the screen we can select which view of the part we want to start with. We can start, in this case, that is the front view. That's the right hand view. That's an isometric view. Obviously, those blocks mean nothing. So I usually go and turn on the preview option. Click. And there I can actually see what it will look like. So that's the plate from the front and from the side. This looks like a good view to start off with. So to place the view, you can just click to place. And now if you move your mouse to the side, it will create a projected view of that component in the direction that you're moving. And you can even do isometric views as well. Okay, so that's a side view and a top view. And then you click on OK. Right, so now I've placed my views. They are quite small. And I can always go and drag them around. This is quite handy to be able to do. I want them bigger, so we can set the scale. Remember I showed you a minute ago how to set the scale. Right click, expand the menu to get properties. And you can set the scale. Let's use a 1 to 2. Okay, that was pretty easy. Add a part and then you can place it wherever you like and do projected views of that. So under View Layout, we use the Model View tool to insert our part. And by default, it opens the projected view tool to do the projected views. I'm just deleting those views by clicking and pressing delete. So, if you, for example, want to make an auxiliary view of something, you can go to View Layout and then Auxiliary View. Now it says, please select a reference edge to continue. So let's say I want an auxiliary view of this inclined plane. Then I just hover close to it and click. There it makes my auxiliary view, and I can click to place the view. Click. It also makes an arrow to show the view direction. Okay, so auxiliary view, very easy. You just click on the auxiliary view tool and then click on the edge of which you want to make the auxiliary view from. Okay, I'm just going to delete that one. Delete that one. Okay, was that easy? Good. So next what I'm going to do is I'm going to add an assembly view over here. So remember I had to make the assembly view and save it as an assembly, and then I can make a drawing of that. So View Layout, Model View, browse for the file. There's my assembly drawing. Click on Open. So that's the In view, that's the main view. I'll start with the main view. Click to place the view. If you want, you can click to place an end view, top view, a bottom view, and isometric if you really want. And then click on OK. Right, this scale is again a bit weird, so right click, go to properties, set the scale to a better value. I don't need all of these views, so I'm just going to delete them. Click, press delete, enter. Delete, enter. Okay, so there I have two views of my assembly. Again, if you want a projected view, all you do is view layout, projected view. Click and click to place the view. One thing to be careful for is once you've done a projected view and you drag it to the other side, it won't automatically change the view direction. It will still keep this view as I specified it initially. So that's just something to be careful for, that you don't do this and then you make a first angle view instead of a third angle projection. Okay, cool. So next thing I want to show you is how to make a section view. Click on view layout and then section view. Pretty easy. Click. Then it says select a cutting line and place it on a view. There we've got a vertical cutting line, a horizontal one, some other auxiliary section view, and a weird line section view. For now, I'm happy with the vertical one. So if I move my mouse onto the drawing area, I get a line that follows my pointer around, and that is a section line. So to place the section view, you go to wherever you want it to be lined up to and click. So there I click to place my section line. Now to accept it, I just click on OK. I'll explain this block in a moment. For now, I'm just going to click on OK. And there I can place my section view. So something that you might notice that is incorrect is, firstly, the arrow points from the right hand side, but this is a left view. So that arrow is the wrong way around. So to flip the arrow direction, all you do is hover over the section line and double click. Okay, so you saw that it now flipped the arrow to the right way around. But what's weird is my section view didn't change, it just has some block around it with little weird hatching lines. So that means that the view is outdated. To update the view, all you need to do is at the top, click on that rebuild icon. It looks like a traffic light. Click on it, and now it is updated. So double click to change the direction, rebuild to actually rebuild the thing or update it. Double click, rebuild. Alright, now the second thing that you might notice is some of the parts over here are cut and they shouldn't be, like the shaft, the castle nut, and the split pin. And that was actually that blue block that appeared when I clicked OK with the section view. That was to select components to not be cut. Now to get that block back again, all you do is you right click on the section view and find properties. Click on properties and you can set many properties in here. View properties, hide or show components, hide or show bodies, show hidden edges, section scope. Okay, so section scope is actually that blue block that appeared when I clicked on the OK button. So this blue block now lists all the components that will be excluded from being cut. So I can now just go and click on them in my drawing view, click, there you'll see it lists castle nut, split pin, shaft, split pin, castle nut. I can't click on the shaft again because then it takes it away. And then click on OK. So now SolidWorks has gone and removed those components from being cut. And there it indicates my section line. So now the problem is, this is just a straight section, it's not an aligned section. With an assembly like this, we typically want to cut through the wheel, step in and cut through the hook at the bottom. So there is actually a way to do that. Sorry, right clicked by accident. Okay, so let's go back to the section view tool. Section view. Click to place the first line. And now I get options. I can make an arc offset, a single offset, or a notch offset. In this case, we want single offset, so I click on that one. Now you might notice there's a little blue dot that follows the pointer around on the section line. So that blue dot is basically the point where the section line is going to stick. So I want it more or less over there, so I clicked. And now if I move it to the side, the section line will be the top half and step off at the bottom. I want it the other way around, so I just move to the top, meaning the bottom line remains the same and it will step up over there. Okay, so I wanted to go through that point on the nut, so I just click and then click on OK. Again, section scope block appears. I usually don't use it now because I can only click the ones that are on the front. So I'm going to have to open the section scope block again later in any way to click the nuts that were at the back. Okay. Click to place the view. Okay, so this is now an aligned, offset section. But again, the arrow is in the wrong direction, so I'm just going to double click on the section line and rebuild. Okay. Now I must just select the shaft and nuts and split pins again. So right click on the section view, select properties, section scope, and now I'm just going to click on all the components I want not to be cut. And then click on OK. Cool, so that looks pretty good. Everybody happy? Yes.
So, let's say you want to invert the section line, let's say it's 2 so you want the other one is in section 45 and the other one is 35.
Okay, so you're talking about the aligned section view when you're cutting through something like a wheel with spokes in it and you want the line to be vertical and at an angle. Is that the one?
Like two plates together. You can't section them in the same direction.
Oh, you're talking about the hatching lines?
Yes.
Right, so let's quickly do that. to change the hatching lines, basically what you need to do is you need to click on the hatched area. On the left of the screen, deselect the default hatching, and there you can select either to change the density of the lines, or you can change the angle by changing the angle icon. Okay, so a good example would be this side plate and that side plate are hatched in the same direction. We don't want that, so we can click on it, deselect material crosshatch, and type in, for example, 90 degrees. And you'll also notice this one has some weird hatching on it. I don't want ANSI 32 or something it looks like. I want ISO, so under the hatching style I can go to ISO steel. That gives me my normal parallel lines. Click on OK. Let's do the same on the left. Click on the hatched area, deselect material crosshatch, select ISO steel, and maybe change the spacing a bit. Okay. Next, the bushing, you'll notice, is also hatched in some other weird way. So I click on the bushing, deselect material crosshatch, and we want it to be crosshatch. So I'm going to go for ISO, and the one that works, that shows cross-hatching is ISO plastic. And let's just increase the density a little bit. That looks pretty good. Click on OK. Right, so ISO plastic is the cross-hatching style. Cool. Any questions? Yes. Alright, the part list I'll get to in a couple of minutes. All the way at the back.
What do you do to get a web?
So with the web, it's actually a bit of a mission, and I'll show you probably in the next class how to do that. You will typically go and turn off the hatching, so select none, and then you will go and sketch in the web feature and then hatch everything except for the web feature. But it is a bit tricky to do, so I'll do that in the next class for you. Okay, now when we looked at this assembly example in class, we actually said that we want the hook to be a broken out section and not a normal section. Now the problem is with SolidWorks, it doesn't allow you to do a broken out section on top of an offset section view. Okay, so this was the offset section, section line C. But SolidWorks, for some reason, is not happy if you do a broken out section on top of an offset section. It does sometimes do some weird stuff. Sometimes it allows you, like now it did allow us to do it, kind of, but this is not what we wanted. So you'll notice that SolidWorks with broken out section on top of a section view does weird stuff. Sometimes it gives you an error, and other times it just does weird stuff. So what I'm going to do is, I'm going to use broken out section. In this case, we want cutting through the wheel and cutting through this part. So I'm going to use two broken out sections on a normal external side view, and that will allow me to do everything that I actually want to do. So I'm going to do broken out section on this view. So firstly I'm going to cut only through the wheel. So now I can set the depth, how deep this thing must cut, by selecting that part. You can see as I cut deeper, it actually does cut deeper into the assembly. Okay, but there's an easier way than setting the depth. I can just go and click where I want it to go through. So if you click on the circle, it places it exactly in the middle of the circle, and then we can click on OK. So that was my first one. I cut to the middle of this wheel, and then the second one I can go and cut into the shaft at the bottom. So I'm going to do a broken out section again. And now I can do my wavy line. Something like that. Turn on preview. And this time I don't want the depth to be over there. It must cut through that circle there. Okay, that looks pretty good. The only thing is now I have this line showing where my section went through. So I can just hide that line by clicking on it. And then the fourth option is show or hide edge. Click, hide. Right click, look for properties, section scope, and then select the stuff that shouldn't be cut. Okay, shaft, castle nut, split pin. I'm still missing this split pin here. Okay. Right click, properties, section scope, nut, split pin, nut, split pin, shaft. Okay, so of the three methods, this one is the best suited to our purpose. This one was just a straight section through the middle, section BB. This one was a offset section, section CC. And this one was multiple or two broken out sections at different depths. Let me just change the hatching on the bushing. And then click on OK. Change this hatching. ISO steel is the one we're looking for. Decrease the spacing a little bit. And now you'll notice one thing that it does is there where my brake line went through. Remember, it's two different sections, so I'm just going to have to change that one as well. Like that. Change that one, lower spacing, ISO steel. And change the angle to 90 degrees. So I'm just typing 90 in there. enter, change this one. And click on OK. This hook and the wheel still have the same hatching, so I'm just going to change this hatching's angle. And OK. Cool. Any questions on how to make a section view? Good. So next one is a detail view. If you have something that is very small on the drawing and you want to zoom in on it, you can actually go and click on the detail view icon. Then it says, please sketch a circle to continue view creation. So if I want a circle over there, I just click for the middle, click for a point on the outside, and then SolidWorks creates a detailed view of that. So the scale used, in this case it did a scale. Okay, so you can change the scale if you wanted to zoom in a bit better. Obviously 5:1 is a bit too much. I'm just going to delete that one because it's taking up space. Right, so now we've done model view, projected view, auxiliary view, section view, detail view, and broken out section. The break view tool is what you use if you've got a very long, slender shape. Do you remember we said if you've got something long, you can make it shorter so that you can actually dimension the side view. Otherwise, if you've got a very long rod, the side view will just be a dot on the paper. So that's what you use the break view for. And crop view is for partial views. If I make an auxiliary view, click on auxiliary view and click on that line there, then I get the entire thing projected like that. But usually with auxiliary views, we just want to show a specific part and not the entire thing. So what you can do is you can use the crop view tool to actually cut this view smaller. So if we click on crop view, then it says, please sketch a closed sketch profile in the drawing view to create a crop view. So I can click on sketch, spline, closed means the ends must touch each other. So there's my closed spline, and then I go to view layout, crop view. So now I've made a partial auxiliary view. Just going to delete that one because it's not on my paper anymore. Okay, so crop view is to make a partial view. Break view is for long items. Broken out section is what we did to make this part over here. And alternate view position is something that I have never used. So I'm assuming you will also never use it. Right. Now to just answer the question from earlier, how to add a table to show your part list. So to do that, you click on annotation. All the way on the right hand side, there's an option called tables. Click on tables. And in SolidWorks, the part list is called a bill of materials. So click on that one. Then it says, select a drawing view to specify the model for creating a bill of material. Now the reason why it asks for that is you could, for example, show an isometric view of your entire machine, but the assembly is actually just of the wheel. So you show the isometric to show where the wheel goes, but the assembly is just of the wheel. So you can have different assemblies in one paper. That's basically what I'm trying to get to. And then SolidWorks just wants to make sure which assembly do you want to use for your part list. So now all of these are the same, so I can click on any one of them, click on the view, and then just click on OK. Okay, what happened? What happened is it made a part list that will follow the mouse around. So I'm just going to click to place it over there. Make some space for it by dragging all of these a little bit upwards. And drag it to more or less where I want it. Okay, so a couple of things with this part list. You'll notice the item number and quantity are not in the same order as in my title block. So all you have to do is you can just click and drag the blocks where you want them to be, the columns. So drag the column to where you want it to be. Next thing you'll notice is it is upside down. We said that we want to number from the bottom to the top. So to do that, you click on the table. Second from the right, you click on table header top. That just flips it upside down. Table header top, table header bottom. Now if you want, you can go and position it nicely above your title block. And resize the columns. Sorry, right-clicked by accident. Okay. Now, for some weird reason, SolidWorks does not want you to delete a row in this table. I noticed earlier when preparing for this lecture, if you delete the row, right-click, delete row, then it also shuffles the order around over here, which I don't know why it does. I can click rebuild, and then if I click rebuild, it puts the header back, but it deletes one of my parts. So that's quite annoying. Just deleting the table, adding a bill of materials again, just to get this one back. So what I found is you can't delete the row to get the heading away. So what I do is I double click in there and delete the contents. Something like that. And then I just line it up with my title block. Okay, so for all university purposes, this is more than good enough. Okay, if you want to add information here in the material column. To add a material, To add the material, all you need to do is hover over there and double click. SolidWorks will then ask you, but are you sure you want to override the reference in this thing? Then you just say drag link and then you can type caps lock, split pin is steel. And you can do the same for all of the rest. Okay, any questions up to now? Yes. It has to detect all of the parts. If the part is listed on the left of the screen, I used drawing view. Which drawing view did I use? Yeah. I referenced drawing view 5. So if the part is in the assembly file over there, if the part is there, then it will have to detect the name over there. Okay, what's also quite nice is it automatically detects the number of parts available and it assigns a random number to it. Now what's quite handy with the number is if you go to annotation and then click on balloon, it actually allows you to add item numbers. Click to locate the balloon, click to place the balloon. And what's handy with these numbers is it automatically references these numbers to the numbers allocated in your part list. So number 7 here is the split pin. That's number 7 there. Number 5 is the castle nut. Number 1 is the side plate. And number 6 is the hook. So all of these numbers correspond to the numbers in the balloons, which is pretty nice. I'm just quickly clicking and deleting those balloons to show you one other ballooning feature. Right, so under the balloon icon, there is one called Auto Balloon. So this adds balloons for all components in the selected views. Auto Balloon, and then it says select a drawing sheet or views to insert. I don't know if I can click that sheet now. So if you click on the drawing view, it automatically inserts all of the part numbers and it lines them up vertically and horizontally as well. So that's quite handy. And then if you want, you can just afterwards go and drag them to where you want them to be. Okay, so Auto Balloon works for simple assemblies, but if it's a very complicated assembly, it will just pop up a bunch of balloons everywhere and you're going to find it difficult to locate the balloons somewhere where you actually can easily read it. Okay, well, once you're done then, you just say save. And then you save it with some other name.